Hi, let's go ahead and look at problem number 8. I've gone ahead and already marked up some of the questions, but we're having 50 milliliters of 4.5 molarity carbonic acid, which they give us the formula, joining, or it says with excess. Remember, excess means basically we're going to ignore it when it comes to the math, but we still need to put it into our formula, potassium hydroxide, how many grams of potassium carbonate are produced. Okay, first you need to be able to recognize your acids and your bases. And we know when we have a classic acid, which has a hydrogen in the front, and then other elements, reacts with a classic base, which is other elements with a hydroxide or an OH, we are always going to get a salt and a water, which is what I went ahead and did here. We have our classic acid. We have our KOH, which they tell us our potassium hydroxide is what we're going to have in excess. Still needs to be in the equation. And then we always are made, doesn't matter the order that you write them. I wrote my water first and then my salt. I found out my salt by crossing out the hydrogen and the OH. So I could ignore those two pieces. That left me with the potassium and the carbonate, which will write your ionic compound. You know, a salt is an ionic compound. Think about that. All right. In ionic compounds, your metal always goes first, then your nonmetal. So I had to go ahead, figure out their charges. Potassium has a +1 because it's in group 1. Carbonate, from what you had to memorize, polyatomic ion, has a 2 negative charge. So that's where I got K2CO3. And I had to go through and balance it. Stand by for part B.